Hello, welcome to this lesson in AC circuit analysis. We have a problem here. We're finally going to start working some problems. We have spent a great deal of time in the last few sections going over the theory of what real power is, reactive power, average power, and a lot of detail understanding what that really means in terms of energy sloshing back and forth and energy dissipated and things like that. But now it's time to roll up our sleeves and solve a simple problem. So what we have is a load here. We don't know what's inside the box. We're calling it a load. We have two terminals coming out. We know the current flowing into this terminal is given right here, 4 times the sine omega t minus 15 degrees, and that's in amps. We know the voltage drop across the two terminals there, which is 100 times the cosine omega t plus 15, and that's in volts. And we're told, or we're asked, to find the average power and the reactive power for the load. All right, so if you go back to the previous lessons, if you've been following me up until this point, when someone tells you, hey, go find that average power, what they're asking you for is capital P. That's the average power. And if you remember, average power is really the integral of that big instantaneous power equation that we left on the board for a long time. It's the integral over one period. And so what you find out is a lot of terms drop away and it becomes a little easier to manage, and we'll write it down in a second. Now the reactive power is denoted by Q, and so I'll just write that down, reactive power. So really what you're trying to do is find your P's and Q's, and that's how I try to remember it. When you're trying to find average power, reactive power, that's what you're being asked to do. All right, so if you go back to the previous lesson or previous lectures or look in your textbook, you will find an equation for this thing called average power. It's capital P, and it is Vm times Im, these are the amplitudes of the voltage and the current, divided by 2, times the cosine of this really important phase angle, which we've been talking about over and over again, theta v minus theta I. In fact, this theta v minus theta I thing, it's probably the most important thing in all of what we've been doing. This phase angle comes up over and over and over again. We've talked about it with the power factors and reactive factors and all kinds of other things. So essentially, when we're asked to find this average power here, we're basically asked to figure out and calculate what capital P is. And so when you look at the equation, you need the amplitude of the voltage, which we have. You need the amplitude of the current, which we have. The number 2, that's easy to go. And then the cosine of theta v minus theta I. Now here's where you get into trouble. The cosine of the theta v, the angle is given to us by 15 degrees. Theta I, you think is the phase angle for the current. You think it's negative 15 degrees, so you just plug it in there and go. That's where you're going to get into trouble. Because you see, remember, in circuit analysis, the way that we're doing it is we want everything written in terms of a cosine. See, this is a cosine, so this is the proper phase angle for the voltage, but the current is written in terms of a sine. So if you just plug in negative 15 degrees there, you're going to get the wrong answer. You need to convert this sine into a cosine. Everything needs to be into the same format, for lack of a better word, in order to get there, or in order to make any progress. So before we can actually use that, we need to convert this. So I of t, we're going to rewrite it down. I of t, what is that going to be? It's 4 times, we're going to change it into a cosine of omega t minus 15. The question is, how do we take this, which is currently a sine, and transform it into a cosine? What do we need to do to it? And the answer is, I'll just tell you and then I'll explain why. You subtract 90 degrees. So here's the 15 degrees, here's the 90 degrees. Basically, when you start off with a sine and you subtract 90 degrees, then you can change this into a cosine. So this is the proper angle here, because now I of t is equal to 4 times the cosine of omega t. And when you take a negative